I'm Björn Wagner from Parity Technologies. Thank you so much for having me today. I'm going to take the next 20 minutes for telling you a bit about our projects together with the Web3 Foundation, which is called the Polkadot Network, and the product that we spun off recently, which is called Parity Substrate. A bit about our company. So we got started 3 years ago, roughly, to set out to build the infrastructure for the new decentral web. And as we believe that in this future Web3, there's a system needed that allows us to manage expectations in absence of these traditional central authorities that we're used to. We really focus on blockchain because we believe that can be the cornerstone of Web3 for expectation management. From starting 3 years ago to now, we've grown to a team of roughly 45 engineers. We are headquartered in London, but have an office in Berlin and also engage with people in Russia, China, in the US. And for all of you, we are hiring. So if you're interested, please come talk to me or reach out to us. For those of you that have no idea what Parity Technologies has been up to over the last 3 years, one of our probably most well-known projects was the Parity Ethereum client, which is a cutting-edge Rust implementation of Ethereum that today really is the backbone of the Ethereum network in some sense, as it's being used by the majority of miners that secure the Ethereum network, as well as many infrastructure players in the space, such as block explorers and so forth. But one point I want to make is that today, this piece of software, Parity Ethereum, is much more than a client that just allows you to communicate and interact with the public Ethereum network. We've abstracted wherever we could and extended it by a functionality such as pluggable consensus. So we have multiple consensus engines that you can power this blockchain client with, as well as 2 different virtual machines. It's not only the Ethereum virtual machine that you would have when you connect to the public Ethereum network, but as well a WebAssembly-based virtual machine that is currently running live in production in the Coven testnet. Beyond the Parity Ethereum client, we have done a lot of work in generally in the blockchain space. We did a production implementation of a Bitcoin client. We are looking into doing one of a Zcash client. We built a WebAssembly interpreter in pure Rust, and many more things. And what we've come to realize over these past few years is that we really don't believe in this one chain to rule them all future. We believe there is a reason why there will be multiple chains, multiple different looking chains. But why is that? So very obviously, if you look at, let's say, CoinMarketCap, or if you read research papers, or you see just this multitude of projects that are coming up, there is very apparently a need for different blockchain technology. Different kind of machines, they provide you with different functionality. But one thing that has become very apparent is that most of the innovation that's happening in the blockchain space is on the state machine level. It's kind of the part of the blockchain software that defines what functionality you're provided with. Take Bitcoin as an example. In Bitcoin, it's pretty straightforward, right? It works almost like a calculator. You have multiple accounts, and Bitcoin very much allows you to transfer Bitcoins from one account to the other. And it does that very well, and it's very easy to reason about its security, how it's doing that. Whereas with Ethereum, you have a much more Turing-complete kind of smart contract scripting language that is more powerful for developing dApps and business logic, but it's also a lot harder to reason about its security. And it doesn't do everything as optimized as it would, for example, Bitcoin would do for its functionality. So we see the need. Different projects have different needs, especially on the state machine design. Not so much on consensus, not so much how the networking works, not so much how the database is implemented. One particular space where we've seen that is the enterprise space. So we've worked over these years, we've worked with a number of enterprises as well as integration partners, companies like Applied Blockchain in the UK that has taken our software and deployed it for enterprises in more like permission settings. And what we've seen is that public blockchains really don't meet these kind of requirements that enterprises have today, especially requirements with regard to permissioning confidentiality. And the nice thing about that, if you think about it, could these requirements be tackled, right? And that, again, is on the state machine level. It's like how the runtime is designed, not necessarily so much how the deconsensus works. So, like, I'm aware of at least 30 more enterprise private permission networks that are running right now in production based on Parity Ethereum. But the really sad thing about that, right, and about all these other projects that we see out there is, in the public space, is that all these wonderful networks that provide some new functionality can't talk to each other. So what we end up with is the same walled gardens that blockchain technology promised to get us out of, right? So, and we end up with the same kind of data silos of functionality and so forth. And that is really where our new project Polkadot comes in. We published the paper, the Polkadot white paper 2 years ago. There is a specification online on the Web3 Foundation wiki. Please go there, read about it. I won't go too much into technical details right now. I just want to give you a rough overview what we are looking at building there. So Polkadot overall is a protocol that enables these different state machines to communicate and share pool security, while eventually, preferably, actually using all these different systems from one node that you run on your machine, right? And that would enable one thing in particular. It would enable faster and better innovation, because suddenly, if you don't have to take care of securing your chain anymore, of incentivizing miners to secure your chain, you can really focus on building the part that makes your blockchain different. And that is the runtime, the state machine. So there are two parts of that I want to talk a bit more about it. One part is the interoperability part. Interoperability has been all the hype lately, right? But not everybody that talks about interoperability means the same, right? When we talk about interoperability, we mean it in a very general sense. It's not just enabling one chain to access assets or tokens on another one, having the functionality to transfer tokens. But what we mean is that these chains, beyond being able to transfer tokens, can transfer arbitrary messages, whatever it is. And in general, we want Polkadot to be very flexible, general, adaptable. We say it should support the past, the present, and the future. So on one hand, it should enable communication with like blockchains that already exist with their own consensus mechanism. Let's say the public Bitcoin network right now, the public Ethereum network. But on the other hand, we want blockchain to be able to annihilate, to really absorb new technology that's being developed right now. Take zero knowledge proof, take ZK Snarks as an example. So we designed Polkadot to enable it to absorb these new technologies. And last but not least, we want to go as far as having in this one Polkadot network the ability to have chains run that are either public or private, more permissioned, less permissioned. And that is possible. We could see a chain being part of the Polkadot network that is fully encrypted and dark. So as I said, when we think about interoperability, we think beyond just token transfers. We mean arbitrary message passing. Another point that I think is very critical to understand, to really grasp what we're trying to do with Polkadot, is that we really try to scalably, securely scale blockchain technology. And that can only be achieved if you pool security. So connecting chains is already hard, but like securely scale then is even harder. And why this point is so important is quite easy to explain. blockchains in general naturally compete for resources to secure your chain. We have a nice image here that makes it a bit more tangible, easier to explain. So if you look at traditional proof of work blockchains, right? They are all secured by having machines run and solve these mathematical puzzles like hashing, just hashing power, right? But there's a limited amount of hashing power in the world. And as more hashing power is being committed to your chain, as more secure is your chain. Which is why there has always been competition around, oh, do I mine on Bitcoin? How can I incentivize miners to mine on my chain, on Litecoin? So, and the problem around that is now, if we say we have hundreds of very different looking blockchains with their different state machines, and they all need to secure themselves, every chain becomes less secure because this pool of resources has to be split up. And the same counts for proof of stake based chains, because also that is a limited resource, obviously, that has to be split up. The money that's being deposited, being staked. Whereas in Polkadot, the way we think is that all these different blockchains have one need that they have in common and where they shouldn't have a conflict about, and that all of them want to be secure. All of them want their finalization mechanism to be as secure as possible, as fast as possible, as good as possible. And we believe we can build a framework, a very flexible general framework that allows all these blockchains to connect into, being finalized and secured by the Polkadot network, where and at the same time, like, look very different. So that's very, in essence, a very nice thing, right? If we enable interoperability, arbitrary message passing, and at the same time, we enable to pool the security, to pool the resources around securing each chain, we can scale horizontally. Because effectively, we have these different parachains, these different state machines running in parallel, collating transactions in parallel, and thereby increasing the throughput. Here you can see a 10,000-foot view on Polkadot. So the system has three very critical parts. One is the relay chain. The relay chain, as the name says, is there to relay messages from one constituent chains to the other. That is one very critical thing it does. The other critical thing is that it secures all the chains on the bottom. It does the finalization of these constituent chains, which we call parachains. And these parachains, right, you have actors that we call collators. They collate transactions. But how this function looks by which they collate, how the state transition function looks, is really very arbitrary. And the framework we use to define the state transition function, right, is WASM. So, and that gives you an additional benefit. That effectively means you can update the runtime. So your state transition function on-chain. You can have code, can have the WASM code that defines your runtime being registered on-chain and being updated on-chain through some kind of governance mechanism. A third part are bridges. Bridges are really there for non-native parachains, so for these kind of chains that already exist and already have their own means to come to consensus. That could be the public Bitcoin network, that could be the Zcash network, right? It's for the foreseeable future, they will stay absolutely independent, but we want to empower any chain that is within the Polkadot ecosystem to be able to talk to these chains, and that's where bridges come into. So where are we right now? We published POC 1, I think, roughly 4 or 5 months ago. It was a running testnet. It included the governance mechanism we envision, staking. We have a basic UI going, and we already did the first proof that you can have forkless upgrades. By having a governance mechanism that can define the runtime on-chain in a WASM snippet, we can circumvent the need for hard forks, so to say, because clients that run the chain can see what the new runtime should be upgraded to and upgrade themselves trustlessly. So POC 2 was I think published a month ago, maybe a few weeks only. And what it really features, it was a proof of concept of this notion of co-finalization, of pooling the security of all these chains to secure any kind of parachain. Currently, it doesn't include communication between the chains, so interoperability on that level hasn't been included yet, but co-finalization is already there and you can try it. You can already go on the testnet and register your new parachain. Say, define a parachain, a state transition function in WASM and interact with it on the live test network. What's next? So what's coming? We have POC 3 coming up. It will most likely include a new hybrid consensus. We will split off one product that I will use the next 2 minutes to talk about. And then POC 4 will be also a very, very critical milestone, which is where we want to have an implementation about the validity and availability games, which really prove that this system can work securely in the end. In parallel, we've been developing tools for parachains that are, let's say, telemetry service. We have a UI and a few other things. You can all check them out on GitHub. Everything's open source, and we are always looking for contributors. So one particular thing that I want to point out that we learned over the last few years was that while like implementing blockchain clients, let's say the Parity Ethereum client for and then the Bitcoin client, is that everyone in the space always tries to reinvent the wheel. So they try to innovate on the state transition level, and at the same time, often they re-implement the whole networking layer. They re-implement the database layer. They do a lot of this stuff that's really not needed and that you really shouldn't care about if you want to build a blockchain client. And that's why from these learnings and from building Polkadot, we spun off a product which is called Parity Substrate. It's fully open source. And it will be split out in its own repository within the next few weeks. The latest, I would say, 1 or 2 months. And what Parity Substrate is, it's a customizable framework. It's a set of libraries that makes it very easy for you to build your own blockchain clients. It provides you with all the plumbing work that you don't want to care about, be it networking, database, be it consensus, and so forth. It's architected on WebAssembly. It's built on libp2p. I want to point out that it was really awesome to work together with Protocol Labs to team up. We in Parity Technologies implemented a Rust implementation of the libp2p networking stack and are looking forward to maintain it over the next few years. Actually, we are running it currently in production in Polkadot in the testnets, this libp2p implementation. And Substrate really is the foundation for Polkadot. Right now, they share a large part of the code base, but what we will do is we will split it off, provide documentation to make it easy for you to make your own blockchain client. It's secure, it's fast, and it's designed with a light client first principle, because we noted that introducing the notion of light clients after building the full node blockchain client is really, really hard. So that was designed from the ground up with light client first principle. And last but not least, what Parity Substrate will provide you with is the possibility to go on-chain chain upgrades, so to say. On-chain governance combined with protocol upgrades that don't have a need for a hard fork, which I believe is very powerful. Current state and more information. Code is in a very good state. It works. Documentation is completely lacking. Please come back in like a few weeks or reach out to us over our Riot, over GitHub or wherever. We're always happy to really support you guys to try to use it. But a good starting point is an article by one of my colleagues called Jack. He wrote What is Substrate, and that's a really good starting point, I would say. I brought you a few resources here that you can check out if that sparked your interest. It's obviously our GitHub repositories, Twitter, our Medium channel, and last but not least, please join Riot, come in touch with us, talk to us for hiring or also for collaboration on other levels. Last but not least, I want to point out again, we are hiring. So if you want to work with us, come forward. Let's do it. Thank you very much.